As we know, a mechanism is a contraption for transferring or transforming forces and motions. Here we'll look at a property of a 4-bar mechanism that describes how well it can transfer a force in its given configuration. Here is a 4-bar. For this analysis, we will treat one of the links as the input, where the input force will be applied, and this link as the output, where the output force will be available. This transfer of force from the input to the output link takes place through this intermediate link called the coupler, and in absence of any other forces, the force in the coupler is along its own length as shown here. To understand the concept of transmission angle, let us consider this output link as a door that we are trying to open or close, and the force in the coupler which gets applied to the output link as the force we are applying to open or close that door. Then as the mechanism moves, the angle between the force and the door changes. Now think of which is the best way of applying this force. Is this a good way of opening a door, or is this a better way of doing that? The angle between this force which acts along the coupler and the output link captures this ease with which we can overcome the load at the output. This angle is called the transmission angle. The closer it gets to 90 degrees, the more effective is the force we apply. Lastly, let us take a look at two extreme situations or extreme values of transmission angle. Here are the two configurations. In both configurations, the mechanism has assumed a shape of a triangle. Okay. As you know, in a triangle, angle is maximum when the opposite side is maximum. So when these two links AD and AB come one next to the other, the opposite side becomes maximum, giving us the maximum transmission angle. And when these two sides overlap, thereby subtracting their length, okay, the opposite side is minimum and the angle also becomes minimum. Of course, we can calculate it using trigonometry, the cosine rule, like this. So throughout its cycle, the transmission angle of the mechanism would vary between these two limits, and it tells us about how well the mechanism will be transferring forces as the crank makes one complete revolution over here.